Our lesson today is to be able to write and compare direct variation equations. A direct variation is when two quantities x and y are proportional. The relationship can be represented by the direct variation equation, which is y is equal to m times x, where m is the constant of proportionality. The graph of y is equal to m times x is a line with a slope of m that passes through the origin. Direct variations will always pass through the origin because proportional relationships pass through the origin 0, 0. All right, over here in the direct variation equation, y is equal to m times x. M represents the constant of proportionality. It also represents the slope and the unit rate. All right, here's our first example. The cost y in dollars for x gigabytes of data on an internet plan is represented by the equation y is equal to 10 times x. Graph the equation and interpret the slope. The equation shows that the slope m is 10. So the graph passes through 0, 0 and 1, 10. If we want to interpret the slope, right, the slope being 10, first we would plot the points and draw a line through the points. Because negative values of x do not make sense in this context, graph in the first quadrant only. And if we're interpreting that slope, the slope indicates that the unit cost is $10 per gigabyte, because here we have a change of y of 10 and a change of x of 1. So that's $10 representing the cost, so a change of $10 for every 1 gigabyte used. All right, so our next example. The amount of money Robin earns while babysitting varies directly with the time as shown in the graph. Determine the amount that Robin earns per hour. To determine the amount Robin earns per hour, or the unit rate, find the constant of variation. So we're looking for the slope. Well, in order to find the slope, like we did in the previous lessons, right, we have to choose 2 points on that line. Right, my change of y here, in between 10 and 20, that's a vertical change of 15. My horizontal change is 2. So my m is going to be equal to 15 over 2, and 15 over 2 simplifies to 7.5 over 1. Well, what does that mean in the context of this problem? It means that Robin earns $7.50, right, for each 1 hour worked. All right, so that slope represents the constant of proportionality and the unit rate as well. All right, let's try a different one. 2 minutes after a skydiver opens his parachute, he's descended 1,900 feet. After 5 minutes, he's descended 4,750 feet. If the distance varies directly with the time, at what rate is the skydiver descending? Well, once again, we have to find that slope or the constant of proportionality. So I can take any ordered pair, right? My change in y is 1900. My change in x is going to be 2. Right? So if I want to find that unit rate, I have to take my 1,900, not 190, my 1,900 feet, which is my vertical change. My horizontal change is going to be the 2 minutes. When I divide 1,900 by 2, right, we get 950 over 1 as my slope. Well, what does that mean in the context of this problem? It means that the skydiver descends at a rate of 900 feet every 1 second, right, in the context of this problem. Next problem. The weight y of an object on Titan, one of Saturn's moons, is proportional to the weight x of the object on Earth. An object that weighs 105 pounds on Earth would weigh 15 pounds on Titan. Write an equation that represents this situation. Well, we're going to use the point 105, which is the earth weight, comma 15, right, which is the Titan weight, to find the slope of the line. Well, the first step here is I start with my direct variation equation. And then I want to replace y with my y value from the ordered pair, so that's going to be 15, is equal to m. And then I'm going to replace x with my x value from the ordered pair. That's going to be 105. Well, we're trying to find that constant of proportionality. So we want to solve this one-step equation by dividing both sides of the equation by 105, and that's going to get m by itself. So when we divide both sides of the equation by 105, on the right side of the equation, the 105 in the numerator is going to cancel 105 in the denominator, and we wind up with m is equal to 15 over 105. If I divide that out by 15, because 105 is divisible by 15, we come up with a slope in m, which is going to be equal to 1 over 7. So 15 over 105 simplifies to 1 over 7. That's our m. If I want to write an equation now, I have to use that m in my equation. So my equation is going to begin with y equals my 1/7, which is my m, times my x. So there's the equation of the line that would represent that situation. Now that we know the slope or the constant of proportionality, we can use that to solve problems. How much would a chunk of ice that weighs 3.5 pounds on Titan weigh on Earth? Well, I'm going to replace 3.5, that's my Titan weight, that's my y value, right, is the weight on Titan, 1 over 7 times x. I'm going to solve that equation for x. Well, x is right now being multiplied by 1 over 7, so to get x by itself, we're going to multiply both sides of that equation by 7. On the right side of the equation, 7 in the numerator is going to cancel 7 in the denominator, so on the left side of the equation, 7 times 3.5, that's going to be 24.5, right, and that's going to be equal to x, which means what would the weight of that ice be on Earth? Well, that would be 24.5, right? And these are pounds, right? So x would be equal to 24.5 pounds. Okay, let's do example 2 down here. Once again, we want to start with our equation. Y is equal to m times x, our direct variation equation. Right? We're looking for, let's see, how much would it weigh on Titan? Well, that's our y value, right? The Titan is the y value, so we're going to replace x with the 3,500. So y is going to be equal to 1 over 7 times the 3,500. Well, 1 over 7 times 3,500, that's going to be what? 7 times 5 is 35, so y is going to be equal to 500 lbs's, right? So the weight on Titan, if it weighs 3,500 kilograms, oops, not pounds, these are kilograms. Let's get that right. So that would be 500, right, kilograms on Titan. All right. About the units up here. Were these kilograms as well? Nope, there were pounds up there. Down here are the kilograms. All right, just double checking the units. All right, let's take a look at the next example here. A cyclist can ride 3 miles in 25 hundredths of an hour. Assume that the distance biked in miles, y, varies directly with the time in hours, x. This situation can be represented by the equation y is equal to 12 times x. Graph the equation, how far can the cyclist ride per hour? Well, if we make the equation or graph it, right, we know that the slope here is going to be 12 because that's the coefficient of x. All right, so we use our ordered pairs. We know that 0, 0 will always be an ordered pair of a direct variation. We have 12 and 1 because 12 is our slope. So if we have our equation, y is equal to 12 times x, and I use an input of 1, 12 times 1, my output would be 12. If I use an input of 2, 12 times 2, my output would be 24. I graph those ordered pairs, 0, 0, 1, 12, 2 and 24. We get the following, right? That's our graph. The unit rate is the slope of the line. So the cyclist can ride 12 miles in an hour. All right, let's take a look at a different situation. A grocery store sells 6 oranges for $2. Assume that the cost of the oranges varies directly with the number of oranges. This situation can be represented by y is equal to 1/3 times x. Graph the equation, what's the cost per orange? All right, well, along the y-axis, right, that's going to be our cost. All right, and along the x-axis, that's going to be the number of oranges. Number of oranges along the x-axis. Now, according to our equation, the information given, the grocery store sells 6 oranges for $2. So I go over to 6 oranges, I go up to $2, I put a point. Well, we know they vary directly, so we know we're going to have a point at 0, 0. All right, so if I draw a line, right, connecting those points, it's going to look something like this. I always like to extend that line when possible. If I extend that line, draw an arrow at the end of my line, draw an arrow at the end of our line, I see that we're looking for the cost per orange. Well, my slope here, let's see, change in y over change in x, right? Change in y would be 1, change in x is 3, right? So that matches the equation we have up there, y is equal to 1/3 x, right? So we have y is equal to 1/3 times x. Well, we want to find the cost for what? 1 orange, right? So we want to find the cost for 1 orange. Well, here's the cost for, let's see, 1 orange. And I see that it's less than 50 cents, right? Because this is cost in dollars, right? And I see that my cost in dollars, right, that's going to work there. So I want to find the cost for 1 orange. Well, my y values, right, represents the cost, so I want 1. So let's see what we have here. The number of oranges are my x values here. So let's replace. We have $6 is equal to, all right, 1/3 times, let's see, x. All right. So if I'm solving that equation for x, we'd have to, did that backwards. Let's undo that. All right. Oops. Yeah, we'll redo that. Reset. So I know if 6 oranges cost $2, I want to know the cost for 1 orange. All right. So let's do it this way. $2 for 6 oranges. We need the cost for 1 orange. All right. So we're looking for that value there. So that means we'd have the equation 6 times n is going to be equal to my $2. Divide both sides by 6, divide by 6, and we wind up with n is going to be equal to $2 divided by 6. And $2 divided by 6, or 2 over 6, is the same as 1/3. So the cost, n, is equal to 1/3 of $1. Well, what is 1/3 of $1? So n is going to be equal to, right, 33 cents for every 1 orange. All right. We continue. The distance, y in meters, that a 4-person ski lift travels in x seconds is represented by the equation y is equal to 2.5x. The graph shows the distance that a 2-person ski lift travels. Right? So there's our graph. We look at that slope there. We see a change in y of 2, a change of x is 1. So for the 2-person lift, we have a slope of 2 over 1. All right. So we have the 4-person lift is represented by the equation y is equal to 2.5x. The 2-person lift, we know the slope is 2. So we know the 4-person lift is faster than the 2-person lift because 2.5 meters every 1 second is faster than 2 meters every 1 second. Graph the equation that represents the 4-person lift in the same coordinate plane as the 2-person lift. Compare the steepness of the graphs. What does this mean in the context of this problem? Well, when we do that, we see the 4-person lift is a steeper line than the 2-person lift. The steeper line means that the rate is rising, right? More meters for every second. So you can see that the graph represents the 4-person lift is steeper. The graph that represents the 2-person lift. So the 4-person lift is faster because we can see that graphically with the steepness of the line. All right. Well, let's compare this information with the other 2 pieces of information that we have. And if we look here, right, I see this ordered pair here, right? So that's going to be 2.25, right, 2 1/4. So that's 2.25 meters every 1 second, right? That's going to be Rm, our constant of proportionality. Well, what does that mean in the context of this problem? It means that the 2 meter, right, per second lift is less than or slower than the 2.25 meter per second lift, right, SEC, and each of those is slower than the 2.5 meter per second lift. So we have from least to greatest, the 2 meter per second lift is the slowest. The 2.25 meter per second lift is a little faster, but not as fast as the 2.5 meter per second lift. All right, let's continue with some more problems. You can use tables, graphs, words, or equations to represent and compare proportional relationships. All right, and if I look here at the table, right, 3 to 15 is the same as 4 to 20, which is the same as 5 to 25, which is the same as 6 to 30. Right, that's a ratio of 1 to 5. I can see that graphically here, right, with my change in y is 1, my change in x here, right, would be 5. So I could see it graphically. I could see it using words. Y varies directly with x. I could see it with an equation, or I could see in the table, right, because my constant change here is 1. My constant change here is 5, right? Change in y to the change in x, that's going to be 1 to 5. All right? The distance, d, in miles covered by a rabbit in t hours can be represented by the equation d is equal to 35t. The distance covered by a grizzly bear is shown in the graph. Which animal is faster? Well, I see the graph. I want to find the rate or the slope. I see that my change in y here is 30. My change in x here is 1. So the grizzly bear runs at a rate of 30 feet in 1 second. Or what is this? Oh, miles an hour. So 30 miles an hour for the grizzly bear, 35 miles an hour for the rabbit. So the rabbit is faster than the grizzly bear. 35 miles per hour is greater than 30 miles per hour. Here's another example. Let's slide down here a bit. Damon's earnings for 4 weeks from a part-time job are shown in the table. Assume that his earnings vary directly with the number of hours worked. Right? He can take a job that will pay him $7.35 per hour that he worked. Which job has the better pay? Well, got to find the unit rate here, which is the same as the slope, which is the same as the constant of proportionality. Now, I could do several different ways, but I'm just going to take one ordered pair. I'm going to do my change in y, which is 112 over $112.50. That's the amount of money you make in a total of 15 hours worked. I want to use that ratio to find the rate for 1 hour. So when we divide 112.5 divided by the 15, right, we get a rate of $7.50 per hour. So which job has the better pay? Well, $7.50 per hour is greater than $7.35, right, for 1 hour, right? So this has the better pay. All right, another example. A 3-year-old dog is often considered to be 21 in human years. Assume that the equivalent age in human years varies varies directly with its age as a dog. Write and solve a direct variation equation to find the human year age of a dog that's 6 years old. First, we start with the direct variation equation. Your y value, 21, varies directly with your x value of 3. You solve that equation for the slope, we get a slope of 7. Once we have our equation, y is equal to 7 times x. Going to replace x with 6, multiply 7 times 6, and we get 42. Which means when a dog is 6 years old, the equivalent age in human years is going to be 42. Right? And that's what this would look like graphically. Right? Okay. Let's try these two problems. And I think that's it, right? Yeah, we'll try these two problems. All right. So, part A. See what we have here. A charter bus travels 210 miles in 3.5 hours. Assume the distance traveled is directly proportional to the time traveled. Write and solve a direct variation equation to find how far the bus will travel in 6 hours. Well, first we start with the direct variation equation, y is equal to m times x. And then we're going to replace y with 210 because y varies directly with x, and x is going to be 3.5. We want to solve that equation for m. So I'm going to divide both sides of that equation by 3.5. Right, divide by 3.5. And once we do 210 divided by 3.5, we wind up with 60. So we get a slope of 60. Now I want to use that slope of 60 to write the equation. So the equation is going to be y is equal to 60 times x. To find how far the bus travels in 6 hours, we're going to replace x with 6. So y is going to be equal to 60 times the 6. So y is going to be equal to 360 miles, which is how far the bus will travel in 6 hours. All right, last problem. A monarch butterfly can fly 93 miles in 15 hours. Assume the distance traveled is directly proportional to the time traveled. Write and solve a direct variation equation to find how far the monarch butterfly will travel in 48 hours. Once again, we start with the direct variation equation. Y is equal to m times x. We're going to replace y with 93. Right? And we're going to replace x with, what's that, 15. We want to solve that equation for the slope, for m. So we're going to divide both sides by 15. On the right side of the equation, 15 in the numerator is going to cancel. 15 in the denominator. And then 93 divided by 15 is going to give us 6.2. So m is going to be equal to 6.2. I want to use that slope to write the equation. So y is going to be equal to 6.2 times x. Once we have the equation, we use the equation to find how far the monarch butterfly will fly in 24 hours. So y is going to be equal to 6.2, and we're going to replace x with 24. And when we multiply 6.2 times 24, we get the distance traveled is going to be 148.8 miles. The monarch butterfly will travel in 24 hours. All right, I hope that these problems have been helpful, and good luck.